on the cloud. Okay, today what I'm going to discuss is known as the. So I have started recording. Let me check again. Yeah, class has been recorded. So maybe within 1 hour or maybe 1 hour, 15-20 minutes, class will be finished today, and then I will discuss about your midterm exam, which will be due next week. Okay. So there will be long discussions about the midterm exam. So I'm going to discuss today linear. What happened? Mixed effect model. Okay. I'm going to discuss today about linear mixed effect model. So you know by this time lot of models, right? Lot of regression models, you know, multiple regression model, and then Poisson regression model, negative binomial regression model, Bayes regression model, lasso regression model, elastic net regression model, as well as quantal regression model, right? These are the models I already discussed in last few weeks. So those models that I discussed are for cross-sectional data. Cross-sectional data. So that means not panel data. What is panel data? When there is a repeated measurement, not longitudinal data, not panel data or longitudinal data. Longitudinal data. So cross-sectional data or panel data or longitudinal data, sorry, not cross-sectional data and not longitudinal data. So the models that I just mentioned few minutes ago, I already discussed those things. But today, linear mixed effect model that I'm going to discuss will be for panel data or longitudinal data. Longitudinal data. Okay. So what is longitudinal data or panel data? So suppose you have these things. Subject 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 4, 4, 4, and then 4, 4, 4. These are the subjects. So first subject has measured his age. It is 9, 10, 11, 10, 11, 12, 13, 14, 11, 12, 9, 11. So 10 is skip. She did not show up. 12, 13, 14 is 15, and 16. So that means the subjects is appearing once in a year. Okay, that is the data is known as the longitudinal data, and then we compute their height, their weight, their body mass index, their blood pressure, something like this. If this is the way data is collected, that data is known as the longitudinal data or panel data. Okay. Now, sometimes this data is also called the clustered data. Clustered. How? Let me give you one example. How this is a clustered data? Suppose school, SCH schools, right? School 1. Okay. School 1. Then school 1 has how many students? And then suppose this is school 1 and then students. So suppose here 1, 2, 3 up to suppose this school has 600 students. Clear, right? So school 1 is a member of the cluster, right? And then the practical example that I'm going to show you is going to use school data. So then school 2, suppose here is school 2 that has a suppose 1, 2, 3 up to 300 students. So in this way, suppose we have how many schools? 160 schools. 160 schools. 160 schools, suppose. And in this 168 school, altogether 8,000 students. 1, 2, 3, and 8,000. Are you understanding? So altogether 8,000 students in that classroom. So in that school, altogether 8,000 students. If this is the scenario, like 8,000 students altogether in that, so this is also considered as a longitudinal or panel data in terms of this school. Here the schools are the subjects. Are you understanding? Previously, this is the subject 1, first person. Here, school is the subject, school is the cluster. In that way, data is coming. Clear, right? Like the way subjects, school. So this is the example I'm going to show you today. So now I want to explain you how to write. You have a question?
The time series data, is it same?
No. Time series data means it is come by the time. It is timed by the time. For example, that is why it is called specifically time series data. For example, GDP, previous year before previous year, all the years. GDP is coming. That is called the data is coming by time. Data is coming by time. Okay. But here subject is fixed. Is several measurements we are taking. That is called the longitudinal data. So time series data also is correlated. So response variable is correlated. So that is why in the time series data, we cannot use multiple regression model. We have to use autoregressive model, which I am going to discuss after the midterm exam, time series model, or maybe last 5 classes. Clear, right? Time series data is not a longitudinal data. Again, longitudinal data or panel data is also called the cluster data. How? One school, 2 school, 3 school, 4 school. One school has 500 students, another school has 300 students, another school has 400 students. In that way, if you consider 100 school, then all the students of this 100 students, all the students of this 100 school together will form a panel data or longitudinal data where subject is school. Clear, right? Okay. Now, remember when I was deriving Poisson regression or negative binomial regressions, my main purpose was to show you how the regression that was given by Galton 1805, how we come into this mathematical equation. You remember? That's the explanation I give in the derivations of the Poisson regression and negative binomial regression. Remember that, right? Right? How Poisson will be put in this format. Poisson probability model, how that should be put in this format. And then how negative binomial will be brought into in this format, and finally. So now the question is, as there are now, suppose now there are math scores. And here is school. Here is schools. So school one. So this school one has 500. So this is school one 500 times, and school two. Because why I said here 500, because that school has 500 students. School two, and dot 2. Suppose that school has 300 students. So they have a math score, right? This 500 student has a math score, right? Could you please shut down your computer, please? Shut down your computer, please. Shut down your computer, please. So I request you, from upcoming classes, you must not open the computer. Please shut down your computer completely. So there are how many students? School one has 500 students. School two, how many students? 300 students. Right? And then this student has a math course. This student has a math score. I want to incorporate all of these things in the model. And then what are the other variable? Socio-economic score. Socio-economic score. So socio-economic score, and then type of school, like type of school. So is this a public school or private school? So try to understand the format of the data. If data is this format, I want to do the predictive modeling. You understand? If someone said that, so it was not discovered like even 60 years or 50 years, 50 years ago, 60 years ago, it was discovered. So this type of data arise, and then mathematicians, statisticians, scientists, they have to develop a new method how to address this type of problem, where there is a cluster, that means school, and you have a scores, and then is this math scores depends on the socioeconomic score. Socioeconomic score depends on the type of the school. So if the students go to the private school, their socioeconomic score is one type, and there is a private or public school. How can I fit a predictive modeling on this data? You understand, right? You understand the background, right? So background is, yes.
First of all, you need to change. You need to convert public and private into numbers like 0.
Could be sometimes. Sometimes we can put it like 0 and 1 or 1 and 2. Okay.
And you leave it like this too sometimes.
Sometimes if you can leave it like that way, in that way you have to change your coding as dot character, as dot numeric. Keep it like that way. When the model is run, and then he will see that, well, even though this is a character variable, as the gentleman put in the code as dot numeric, I have to change it to the numeric. Okay, so you got the background, right? You got the background when linear mixed effect model is appropriate. Linear mixed effect model is appropriate for this type of data when there is a cluster type of data, and we have to make a predictions for, suppose, the math scores or performance of some English score based on socioeconomic score of that schools or surrounding schools from where the students are coming, and other type of variables. Okay. After doing this, now let me take you directly to the derivation part. So mathematical derivation. I uploaded a document. That document has a heading linear underscore model underscore, I think, let me check in here. Let me tell you from there. But I don't want to. D2L. Mixed model note. Mixed model note. If you read it with your full attention, it might take you a maximum of 45 minutes to 1 hour. Okay? Maximum. The school example that I have given, it is from this note. And very easy format it is written. So I put lot of material, but I ask you read this one. This is altogether 24 pages. So if you read those things, you understand the things very easily. Clear, right? So for the linear mixed effect model, whether you read other materials that I uploaded or not, but please read this one. Mixed model note. Mixed model note. Okay? Read. Mixed model note. Okay. I am starting now derivations, okay? Clear, right? Everyone understand, right? So read this one. So I can write here y, I, j, where this is response variable. Response variable. Ith individual. Ith individual measured at time Tij, where I takes value 1 to up to n and j takes value 1 to up to nj. What is the meaning of this? Here I equal to 1 to n means there are altogether n subjects. I equal to 1 to capital N means there are altogether 100 schools. Okay. So capital N means there are 100 schools, and small nj means if j equal to 1. For example, if I put here y 1 7, so that means in this case means, yeah, so ith school, like the first school, has 7 students. Okay. Yij. So you may be look. So j equal to 1. J equal to, I put here 7, right? So j takes value 1, 2, 3. If equal j equal to 1, first school has only 1. So nj. So number of j. So here I put here nj. So when I put a specific number 7, so that means that has the 7 students. You are confused, looks like. And is a number, right? And it is varying, right? So now if I put here y 2 9, second school has a 9 students. So if I put here y 7 23, seventh school has a 23 students. What? Okay. Yij is the response variable, dependent variable. Okay. So I am formulating everything systematically, bringing it to a very beautiful mathematical formula. Why that stands, how that come into an existence, right? It is not like someone walking in this way or one day in the morning waking up and write some equation and say that this is the, whether you believe it or not, right? It is not like that way. So Yij means response variable. So response variable for what? Panel data, longitudinal data. So why I7 means I equal to first school has a 7 students. Second school has a 9 students. And seventh school has a 23 students. That's the way YIG stands for. Okay. And now we can write it in, as I mentioned, like if I want to write it, first school, second school, and third school. In this way, if you want to write in this way, so school, now you can write here Y, suppose 1, 1, and then 1, 2, and then 1, 3, and then it will go like 1, suppose 200. Understanding mathematical notation is important. And after doing this, now we want to go, as you understand the notations, now we are going to apply here two-stage approach. Two-stage approach. How does two-stage approach starts? Is clearly read, right? Like first stage. It assumes subject-specific linear model. What do you mean by subject-specific linear model? Subject-specific I for subject I put here I, and Ji and beta I, and then epsilon I. Okay, I equal to 1, which is a first school linear model, right? So I said subject-specific. I equal to 1 means first school's linear model. I equal to 2, second school linear model. I equal to 3, third school linear model. I equal to 168 schools linear model. It is starting from each school is started. Now I want to convince you one thing. Are you understanding what I said now? I equal to 1 means first school linear model. I equal to 2 means second school linear model. I equal to 3 means third school linear model. In the sheet, you have a question?
So I represent
Yeah, I specify cluster. So in terms of subject, if it is in terms of subject and subject is matter multiple times, then I stands for the subject. For example, all of us, suppose altogether 30 persons are in this classroom, right? In next 20 years, each of us will be measured at least one time. Each of us will be measured. So how many times? Maximum measurement 20 and minimum measurement maybe 15, 16, 17, 7, right? Everyone clear, right? Understand? I equal to 1 means first school. How many school is in there? 160 school, right? Okay. Each school have a minimum math score, right? And that minimum math score will be different for different school, right? Do you agree or not? There are 160 schools. Each school has an average or minimum math score. So you remember when I do the intercept, so intercept target is to reach in here. Target is to reach 10th floor, right? Right. So if I start from there, I will be a slower starter. If someone starts from there, he is a fast starter. He started from advantage, right? Right. He starts from the advantage. So this is a slope, right? This is the intercept, right? So each school will have a different intercept. Do you agree or not? Because each school average math score will be different, right? So then what is varying? What is random? Random is the intercept. Random is the intercept, and also random will be the slope. Do you understand these things? Because each school, their average math score will be different, right? Their starting point will be different. So school 1 starting point from there, school 2 starting point from there, school 3 starting point from there. So they have a different intercept, and in some cases also slope, unless we assume that slope, like means change of rate is same, but all the randomness is coming from the intercept. Do you understand? You understand these things? Let me again rephrase these things. I have a school in this format: y1, y2, y3, y4, y160, because I have 160 school. Why 160 school? And then each school's linear model is this, right? Each school linear model is this. In this linear model, beta I is the what? Coefficients, right? So each school will have a different betas, right? That is the point. Like scientists thought like that way. Well, we are predicting, we are setting up model for all school together, but each school will have a terms that will be random. It is not fixed for the all school, right? So that will be the random, like what will be the math score for this school? What is the math score, that score? From that, they are assuming randomness in here and changing these beta I values. That will be our second stage. First stage is assume subject specific linear model. Subject specific linear model. Subject. Now they are going to change this beta I. Why? Because every school will have a different rate of math scores. So from there, they are going to change it. What? I already mentioned that I equal to 1 means first subject specific model, I equal to 2 means second subject. Now let me specify these things. What is GI? So you will understand more deeply about these things when I will give the real example from that note. GI is a N times Q, Ni times Q, matrix of non-covariate. And beta I is a Q-dimensional vector of unknown subject specific regression coefficient. So let me again, which one? This one?
So before the beta,
This is ugly ZI. Very ugly, this one, right?
yeah.
So beta is a Q-dimensional vector of unknown. So here I am fitting that many model: 1, Z1, beta 1, epsilon 1. Second school, this is the second school. Beta 2, epsilon 2. This is the 160th school. 160 beta 160 plus epsilon 2. 160. Okay. Now what we are going to do, actually, we are going to make a change in this part. Where? In these betas. Because why? You could ask me the question why? Because first school data I can take, I can feed the model. That beta must be different from second school data, right? Second school data I take, I feed the model, I got beta, that beta must be different from that beta, right? Understand? So now, if you plug these beta values, they are considering here beta I, they are representing, these beta I, they are representing ki beta plus bi. This is another random term. What they are doing in here, they are forming another regression models. These beta i's, how many beta i's I will get there? 160 beta i's, right? So they are forming another regression model, another predictive in this format. And then this BI also called the random like the way epsilon, but these and that are independent. Do you understand their rationality? So as I said, feed only for the first school, feed only for the second school, feed only for the third school, and feed only for the 160th school. This beta 1, beta 2, beta 160 will be different, right? So this is the idea. They said, well, now let us model these beta is like that way. They just model these things. And now they will combine all these things together. These two will be put in one. These values of the two will be put it in one, and then they will get this by plugging two in one. We get yi equal to gi beta plus bi. Okay. So now if you write like this way, gi kib, this could be written as xi beta gi bi plus epsilon I, where xi equal to ji ki and ji bi plus epsilon I. So what is ji? Ji is the covariate, and I will show you how these two things multiplied and become xi when I will give a real life example. Clear, right? So that's the idea how linear model, linear mixed effect model come into an existence. So after this is done. Here is the explanations, okay? These two things equal to that. So when I write something, so let me write here xi equal to zi ki. And then this bi is similarly normally distributed at 0 and standard deviation sigma square, something like that, like the way epsilon. Okay, this is a random noise, random error. So what are the main idea? Main idea is if you have a cluster data, first you have to model by each cluster. Each cluster, then if there are a 200 cluster, then 200 regression parameter, those regression parameter vary. So what way they vary? They model it like this way, and then when they plug these two in original model, now all data sets comes in here. Okay. So after doing this, anyone has a question? Online person? Eric, do you want to speak? No. Yeah.
No, sorry, Professor.
Yeah.
This model must go through the clusters one by one and fit them one after, because like it's unrealistic to fit some of them when it's to have some of the clusters.
No, this is not go by cluster. This is go by all data. So the data is in the cluster format, but when all of this, they will go by all data. Now, it started from there, but when I put the condition which I'm going to show, I will give a condition is there that school will be my cluster. So for corresponding to school, we get a like random intercept, but we will assume that the slope would be constant. In this, after this line, all data together now. Now all data together in here.
That's all the things.
Yeah, all data. Okay. Okay, if I want to give an example from here, so suppose there is a school, and then each school has a subject, right? Each school has a subject. Suppose I want to model these things, math. Now I'm going to discuss these things in this from this paper instead of writing what I wrote, because if I write it in this format, then it will be similar to the one that I have derived in here. Okay. So it is very explicitly written on the page number 11. Suppose math is my score. And then I want to write here I and J. Okay. So then I want to write here alpha 0I, because this is I is the first school, and then alpha 1I first school, and then C S E S I J, and then plus E I J. Let me explain what does this mean. I put here math score I J, ith school and jth student. Understand? Ith school. It is ith school, so that means the slope is coming, the student is coming from the ith school, so this will be the intercept for the ith school. Understand? This is because the student is coming from the ith school, so this is the intercept for the ith school, and this is the slope for the ith school. This is the I slope for the ith, and I am my predictor variable is SES. Socioeconomic score, but it is centralized. C means centralized. Centralized means what? I have a score on the basis of the area. I give some a negative score, some is 0 score, some is 1 score. Suppose who have a less than average income, I give them negative socioeconomic score. Understand? Who has the average income in area, I gave them a 0 score. Who has more than average, I gave them 1. This is a very famous data. If you read the note, you will understand. So, and then I make the data centralized. What? Centralized means from each data, I subtract their mean. So that is why it is centralized socioeconomic score. Clear, right? And IJ. This is ith school and jth persons. ith school and jth persons. And this is the error term. Now, in this case, alpha 0I, if it is measured at, like the way previously I wrote, 0, 1, and then now I want to put here mean socioeconomic score for the I, plus 0, gamma 0 to, and then I put here, suppose I put here, here it is written sector. So sector means public, school is public or school is private, something like that. So I put here a sector. and then I put a arrow U, like the way the arrow that you are seeing in here, 0I, it is similar to that BI. That is similar to BI. It's random. Okay, so now take a look at that. These things I express like that way. Similarly, this one I have to also assume. What's the rationale? Rationale is that by school, intercept and slope vary. That is the rationality. So if you fit a regression model for the Western Illinois University students math score, and if you fit a regression for the Northern Illinois University of Chicago, then you will get different intercept and different slope, right?
Yes.
So by borrowing that idea, they are plugging in here because the data is clustered data. So this will have a that format. Also, we will have a that format.
Because
Yes.
zero, C,
Which one?
infinity, one.
This one?
Yeah,
Now, neither zero, neither infinity. This is alpha, I said.
alpha zero I.
Yeah, because this is a math score for the zth individual in the ith school.
What does the I in front of the
Math. This is math.
not down, you want down.
Here. Okay, so let me write in here math score.
Professor, there's just one predictor.
With this predictor, if you plug in there, more predictor is coming.
But what what's the predictor doing from that?
Here,
Yes.
mean SES, socioeconomic score, that has a mean.
What does this?
ith school has a, if you plug I equal to 1, if you plug I equal to 1, that school will have a mean socioeconomic score. Okay. And then if I equal to 2, then there is a mean socioeconomic score. But each school has a students coming from different region. So from the different region, their each student socioeconomic score is different. Yes.
This alpha is facing down. What does it mean? That alpha.
This one,
Yeah.
this is gamma. This is not alpha. This is gamma. No, anyway, well, like maybe he is purely coming from business background.
Yes.
Yeah.
Okay. Take a look at that. Math score of the zth individual in ith school. Clear, right? So I am modeling math score of the jth individual in ith score, and this is the ith score slope. ith school slope, ith school intercept, ith school slope, and this is my predictor variable. This is a random term. Now, as I am modeling clustered data, each intercept and slope should be different. So now I am modeling them. So next one, I am modeling in here. 1I could be modeled as 1 0 1 1 mean SESI plus gamma 1 2 sector I, here is I plus U 1I. Okay, now let us plug these two things, these values I want to plug in now here and there. Okay, if these values are put in that place, these values are put in this place, then we are getting in here math ij equal to, we are getting this mean SESI zero to sector I C SESIJ plus gamma 1 mean SESI and CSESIJ gamma 1 to sector I CSESIJ plus U0I U1I CSESIJ plus epsilon ij. Take a look, this one, there is a two term, right? There is a two term. Like the way we got two term in there. Are you seeing two term I got in there? So, sorry, these two. And this one is independent only one. So this is that one. So the way that model is written is coming exactly like that. Okay. So let me conclude this thing by telling very plain one. We start with the subject model. If longitudinal data come in the format of the subject, each subject has a 5 measurement, 7 measurement, 10 measurement, 20 measurement, we have a model. But my data, the slope and intercept that is coming from my data must be different from your intercept and your slope, right? Suppose your height, your weight, your systolic blood pressure, triglyceride, cholesterol, all has been taken, and then your dependent variable is blood pressure. And then beta 0 and beta 1 will be different from you and I, right? You understand?
Yeah.
So beta 0 and beta 1 will be different. So what they are doing, well, as it is different by the subject, by the school, let us change the slope and intercept. So that is what the slope, this is the model, original model for each individual of a particular school, and now in the particular school has a different slope and coefficient. Now we are modeling them. Once we plug all of this, now this has become our permanent model. So our permanent model is going to be like this. Okay. So if someone down the road will ask you longitudinal data, linear mixed effect model, how is different from the or maybe in the interview questions, if they will ask you in the predictive classes, what are the models you have done? Interview question. So I saw your transcript or your resume, you have taken predictive analytics, predictive modeling. What did you learn from there? If you said that we learned Gaussian regression, negative binomial regressions, linear mixed effect model, quantum regressions, all of these things, at least you have to answer what they are doing. So if they will ask you, tell me why you will use negative binomial regressions, your immediate answer is that response variable will be count data, mean and variance must not be equal. Okay, that will be your answer. Because ultimately you are going to write all of these things, your statement of purpose and your CV, that predictive modeling, we have learned these things. They will ask you, what did you learn from lasso and how does it different from the rees or elastic net? Then you wrote these things, you are unable to do these things. You understand? So whatever you have written in your CV, it should be in your head. Okay. If you cannot answer from there, and then if they will ask you how does it different from linear model and linear mixed effect model, how is it different? You first answer will be linear mixed effect model will be for the longitudinal data or cluster data. Then if they will ask you how, then you will say that we will feed one model for each cluster. Cluster vary by the slope and intercept. So we have to model slope and intercept. Understand, right? So that's the things, all the data is coming in here. So for my question, one person did not get a job at a university. I did not expect, my question was not to insult the candidate who was visiting. My question is general question. So how can you interpret these things? So why it is called the linear model? So let me ask you, why this is called the linear model? Y equal to, could you please stop talking in here and shut down the computer? From next time, you must not open your computer. Please shut down your computer. From next time to the class, if you come, you must not open your computer. And it is a disrespect to your professor when your professor speaks and you are talking. I am a very kind and very helping professor, believe me. Understand? But when I become strict, I am very, very strict. I am asking you a question, why it is called linear model? Okay, one of you asked me why this is called the linear model. What makes it linear? What? Why this is linear? Why this model is called the linear? What? So in this model, what part linearity exists? Where does linearity exist in this model? What?
The X1I and the X2I.
No. See? You already learned so many models. X1I, X2I does not determine the linearity. X1I, 1Y, X1, X2, these are numbers. This is called the Y equal to suppose SBP or like blood pressure, XI equal to height and X2 equal to weight. These does not determine, there is a, so determination is coming from betas. It is a linear in beta. So in this case, Xi's are some numbers, variable. Yi is the response variable. But whether the line will go that faster rate or that slower rate or that slower rate or that slower rate, that will be determined by betas, beta 1, beta 2. In the linear equations that was developed by 500-600 years or 1000 years ago, this is the linear equation y equal to mx plus b, that is written, that you have learned from the geometry, mx plus b, that is called the slope. Slope means rate, how fast, how slow you can go, and this is called the intercept. This is not the linear in x. Do you understand? After taking the classes, and then if I write you recommendation letter, and then if you cannot answer these questions, then they will raise questions about you. In the first class, when I discuss these things, I discuss. Anyway, sorry for the little bit of digressions from what I was discussing. So remember, the way linear mixed effect model come into an existence, each starts from a subject level model. Each subject has a different slope and intercept. On the different slope and intercept, we model again, and finally we combine all of these things. We come up with this type of things. So are you seeing here two variables, these times that? This is two variables multiplication of these two multiply, you will get a number. Okay, these two multiply, you will get a number. These two multiply, you will get a number. You have to create another variable from these multiplications. Okay, and then you will end up with this type of model that we end up with. After multiplying this, so betas is the parameter, these two multiplication is giving this, and then zi and bi, this is our original covariate, and then bi is coming randomly, zi is the covariate. In that way, all the final parameter will be solved. So for example, take a look at this. This is the way it is coming into an existence. So if you see some multiplicative term, it is coming into from the derivations.
Because the sector is categorical variable.
Categorical variable.
If we multiply it,
It should be 1 or 0, something like that. So some cases it will get 1 and some cases it will get 0. In that way, they might consider one as a reference and other one as a comparison variable. Clear, right? Okay, now let me take you to the R code. In order to take you to the R, mixed model R code, I think download this one. Let me open the R. Okay. So that is the example I discussed. Let me discuss these things. Let me delete that one also. So first of all, I run a library LNLME, and then another library, and this is the data. So let me show you the head of the data. This is the data. Are you seeing school? School has a number. It has a number code 1224 and minority, and this is the gender, and this is the socioeconomic score, math achievement, and mean socioeconomic score. So mean socioeconomic score for the same school 1224, 1224. So mean socioeconomic score is the same. Okay, so if I take a look at the dimension of this data, math, so 7185. But this is the school. So after that, another one is this is another data. One is math achieve and math achieve school. These are the two different data. Are you saying in this case we are saying public and Catholic school, and there is also other variables? We have to combine these two data to make a one data. You have to attach these things. You know the R, right? You know the R because statistics students, they know R than Python. So when we attach, that means we do not need to declare the name of the data for the variables that we are using. So after this, so we are creating the data in here. I have also written some comments in there. Comments in there, for example, what I'm doing in this part. And suppose I want to take 20 Catholic school and 20 public school and want to see their behavioral, their behavior of the slope and intercept. How does they perform? So, okay, so what happened in there? See if I did it correctly from there. Okay. Let's see now that one. Object school not found. Thank you. So if I do not attach, I have to put the name of the data in front of the each variable. Okay. So now we are trying to see what we have done. 20 private school and 20 Catholic school. We have taken a sample and then we want to take a look at the behavior of the slopes and intercept. So that could be done by beautiful this graph. So that's the way we are seeing how this is starting from there. This goes like this. This is the data point, and data point they have put a scatter plot where x-axis has a socioeconomic score and y-axis has a math achievement. And this is the school number. 4886 is the school number. Its characteristics like that. This characteristics like that. So now are you saying it is going like that way and that is going like that? So this intercept is different from that intercept, right? And see, this slope is faster compared to that slope, right? The main discussions that is taking place today, we started from a subject model. Subject model has a parameter slope and intercept, but for different subject, that slope and intercept is different. So that is why they're modeling on that. Why? The rationale is this. Like if someone asks you questions, you are fitting the model, why did you create this graph? This graph has been created by taking 20 Catholic school and 20 public school, and then we draw this individual fitting, we do this in order to show that the behavior of the intercept and slope are varying. Okay. So this is for the Catholic one and that is for the public one. This is for the public one, that's the way. Okay, after doing this, let me take you to the paper note here. Download this, open. Okay. Most of the thing is done and R code is given in here. This is the R code has been given in here. Your responsibility is to read this document thoroughly. When you write the report, if you run the code that I have provided and just discussed, you will get this type of graph you will get for the data. So this is further, are you seeing this is intercept for the Catholic school and this is the slope for the Catholic school? Okay, so why we have, this is the confidence interval for the intercept, confidence interval for the slope for Catholic school as well as for public school. Why we have done this? Because this is varying, right? Are you seeing? If it will not vary, then the picture will be like this. The confidence interval picture should be like this. Then there is no rationale to use linear mixed effect model, even though there is a repeated measurement, we do not need to, because the confidence interval is almost same, right? Or other way, if I take that one, if all of this line is similar, all of this line starting point is from the same, okay, then no need to use linear mixed effect model, just the general regression model is enough. Are you understanding, right? You are understanding. So in your lifetime, suppose if you want to work as a predictive modeler for a company, and then if you have to handle the customer data, and if you know by chance customer ID, because if you open an account in the Amazon or maybe now Timo, if you have an account, they have a customer ID number, right? And then customer ID number, they can give you as a predictive modeler. Well, this is the data from yesterday's click, check all of these things. And then check these customers for last 1 month or 2 months and 3 months and find the result. So in such a case, this data is longitudinal, right? You have to fit this type of model. Are you understanding, right? You have to do this type of modeling. And then after doing this type of modeling, what they will do, if you buy something from Amazon, and then they will immediately give you a suggestions. The guy who bought these things, they also buy these things. You want to buy these things, those type of things is coming after doing this type of analysis. Clear, right? So most important thing that you must read these things all the way, and here you are getting the intercept of, this is still all the intercepts of the 20 model, something like that. So this is the value. So school that has intercept this, school that has intercept this, school just 10, I took 20 school, but here I am putting just the 10. In this 10, see, highest value is 16, lowest value is 7, right? So that is clear that the starting points is different, intercept is different, and then slope is also, see, negative to positive value slopes, right? Positive 2 to negative 2. So that means 4 points slope difference. And this one for the public list and that one for the Catholic school. Okay. So each time I come to the class, I try to refresh my old knowledge by the new knowledge. So this is the paper today I find it. So let me find something new. And then after reading this, I say, well, this will be very interesting thing. In that way, if I explain these things, the student will understand. So previous year, when I taught the linear mixed effect model, I did not show them, like I told them verbally, but I did not show them the figure. That the 20 figures that you are seeing, I did not show them. But now you have seen the figure, it will be in your head, what's the rationale for using linear mixed effect model. Clear, right? So after reading these things, so, and then you have a intercept, Catholic and public. Now this is a 2 box plot for the intercept for the Catholic and public. That is also different. So which is a justification of using linear mixed effect model, because they are minimum, maximum, and everything is different. Similarly for that one. Okay, so you can say further that in case of public and Catholic comparison, we see that slope value for the public one is higher compared to the on the other end, in the Catholic one, the intercept value is higher, right? So first quartile, second quartile, third quartile, all of this. After doing all of this, then there is a mathematical explanation that I just give to you, how this come into an existence. And then there is this type of fitting in there. Here is the fitting. So let me explain these things. The questions that you have asked me. Are you seeing in this case, LME, linear mixed effect? Okay. Math achievement. Math achievement we are doing in here, mean socioeconomic score, and this is a centralized socioeconomic score. How did this come into an existence? This has come into an existence from the formula. Okay, this is come into an existence from the formula, and sector and these, and then random. This is a fixed effect thing, and random effect is coming from the school. So random effect is saying centralized socioeconomic score, and then this is a random effect is coming from the school, given school, and this is the data. After that, after running this model for your homework, then if you write the summary, this output will be given. Okay, so this is a page number 12. Read this page number 12 very carefully. The way they have interpreted, you have to interpret exactly same way for the homework problem. Understand? Page number 12 has the code. As I mentioned, our randomness is coming from school, right? Randomness is coming from the school. So we put here school in this format, and then this output is obtained. How this output is explained is mentioned from here to all the way in here. Very carefully they have explained all of these things. That is the end of everything. And then if you understand all of these things, then your homework problem, you just copy the comments from there and plug it in there and explain it for your data. Yes.
So all of this.
Yeah. But you have to understand, right? You have to understand. So take a look at this. This is a fixed effect. Are you seeing fixed effect? So this explanation is similar to the simple linear, multiple linear regression model. Okay. So, and this is the random effect. Here is the random effect you are getting. And then here is a correlation matrix is provided in here. And they categorically mention very beautiful things in here. Okay. Today I read this paper 2 times. And then 3rd times I read after coming to the office. So I think this is a very relevant and very beautiful paper if you read these things, so you will understand. Now a lot of especially in the economics, so if you want to work with the suppose 20 countries and 50 years data, then this is what panel data, right? So if you go to the World Bank website and download the data, have you ever been to the World Bank website? No. So there is a lot of data. If you want to do research, a lot of data in there. If you go there and download the data by country, and then by some variables, download the data. After downloading the data, then if you want to feed the model, this is the model. 20 African countries, last 50 years GDP data, and GDP growth you want to predict from what? From education level. And then from like what it called, like the per capita GDP growth, per capita GDP, then education level, and then like marital status, they are like longevity of the people, like gender, and then other things. So let me see if I can help you quickly. World Bank data base. World Bank data base. Let me see. Data bank World Bank. There is a keyword that I have to mention. World Development Indicator. Yeah, Yeah. So you will do these things. Okay, let me send it to you now. I'm good. Next few minutes, put attention in there how to pull the data. Okay, copy, go there, T12. Do you want to take 2-3 minutes break? 5 minutes break?
That would be great. Sir.
Okay, just take 5 minutes break, then I will show you these things.
Thank you.
So, fast homework. So some of those are data analysis, data mining questions. Some questions will be right. I give you data. You go to the Western Online, download this data, and from this data, consider a dependent variable of your choice and fit this model. Yeah, also sometime, but there is no derivation. So you have to understand like when we should use less. Okay. And what is the advantage of elastic net over the less? So when should you use like content liquidation method? Those are the questions.
So I always see that. That would take
Okay, so it's almost 5 minutes. Take a look. Is everybody here? I sent you the link. I sent you the link in your email.
We got it.
Okay. So now, if you want to do the research anytime, there is lot of data in here. The link that I sent, if you click there, you will immediately go to this page. Okay. So now let me click on the database. If I click on the database, are you saying? So 85 database is in there. Yes. Data is not 100% clean. Some of those things you will have to change. For example, the World Bank data, all of these things has been developed in Western countries, right? They have a better systems for all the, like the data to keep to secure place, right? So that is why in the developed countries, if you search the data, you might get all the data. But for the developing countries, not possible. So some cases you need to clean. So take a look at the, if I click on database, these are the 4 characteristics you have to use. If I click on there, this database has how many data? 85 types of database, 85 types of database, okay? World Development Indicator, Education Statistics, Doing Business and Jobs and Quarterly Public Sectors. If you read all of the African infrastructures, railway, and then there is a, what is aircraft, something I have seen, Africa Infrastructure Airport. And if you read economic fitness, mixed market, labor market, lot of data. Now I want to World Development Indicators. It is selected, okay? World Development, but there are 85 databases. You can find lot of data. If someone will tell you, okay, I want to do research, I do not know how to find the data, this is free. Okay, after doing this database, you have selected only one. So that is why selected is one, right? One is selected. And then click in there, it is gone. Now you come here in country. Okay. So if you want to choose the country, then country you can choose some comparison things. You want to compare G7 countries, USA, Canada, Germany, and then some other very underdeveloped country like Bhutan or Burundi or Nepal. You understand, right? So these top 7 countries and bottom 7 countries, I want to compare these countries. How many countries you have to select? 14 or 15 countries, right? You should go there and select these countries. For example, I just want to select here maybe Canada I want to select, and maybe some China I can select, and maybe Chad, maybe Cameroon, something like that. So how many selection? 4 I selected, right? So now country selection is done. Now if you come to the series, in this series, you can select what do you want to select. If you click on the G, then see GDP. I click on the G, GDP, then you can select like GDP. All the GDP related things you can select. GDP per capita. So series is done. Now time. How many years you want to select?
10 years.
So 10 years. So that is not 10 years. That is 20 years. That is 2013, right? Right?
Yeah.
See, all of this has been selected, right? So now if you go there, download options, apply changes, downloading, this has been done. Now if you go there, download options, if you click in there, CSV format, Excel format, whatever format. Okay, CSV format, it is downloading. Data has been downloaded in there. Okay. Lot of data, demographic data, population data, child mortality data, maternal mortality data, infant mortality data, lot of data is in there. You do not need to go anywhere. Just download the data, do the research, keep the paper publishing. The more paper you will publish, you will be known to the rest of the people. Okay. This is called all database. Here is, you cannot believe how many data is in there. All types of, and like population growth, contraceptive using, then HIV death, and then other, what is the other thing, like the African disease? What is that one? The one virus that killed Ebola. Ebola, all of this in there. So when Ebola erupted, I was a postdoc fellow in NIH. I was a postdoc fellow. I was in the 2nd floor. Just one top floor, Ebola patients came from. Yeah.
You are away.
So we are we are in the second floor, just third floor, but they never disclose it. After he get rid of the disease, then they let us know that there was a Ebola patients. But those people are very great and generous, right? Like the doctors without boundary, they risk their life, they go to treat their patient, right? Those people, very, very great people. So you have seen how to download any type of data. I have shown you just only one indicator. If you go there, see jobs, and then population estimates and projections, world governments. Are you seeing health, need, health and nutrition statistics? I don't know what happened. Global economic monitor. And not only that, they make it in other languages also. No, I don't want to go there. So this Spanish, French, and then Chinese and Arabic. If you want to do research, that is enough. And there is also another, fat data. Fat data in Missouri, St. Louis, Missouri. Fat data, St. Louis, Missouri. Federal Reserve data. I don't know why this comes here. Here. Fat data, economic research fat data, lot of data like GDP, inflation, unemployment, real GDP, per capita unemployment, all of these things is in there. Similarly, if you click one of these, and then there will be open CSV format, gross domestic product, and are you seeing download? You will get the data. Fat data and these data, the lot of research is going on all of these things, and sometimes they need to combine these data. Okay. Okay, let me talk about next few minutes. Let me talk about your midterm exam. Okay. So the class will be in-class exam. Okay. And when you come, you sit by leaving one seat blank between you. Okay. No use of the cell phone and WhatsApp. I'm going to the end of the classroom and I'll sit at the end. You have to bring your computer. It's open book, open note exam. And the first things I taught you data analysis, right? By 80 problems, something like this. Right? And then there are some basic computations thing, like how to find the summation and do the functional computations. And then third lectures, I started with the Poisson regression. And negative binomial regression. So the one questions that could be when we should use the Poisson regression and when negative binomial regression. Okay. Then I discuss Rees regression, lasso, and elastic net. So how these regressions are different from the multiple linear regressions? What are the advantages of Rees regression over multiple regressions when Rees regression is used, right? And then when lasso is appropriate, how elastic net is better than lasso and Rees regression. So what type of penalty Rees regression use? For the two-dimensional case, the figure of the penalty looks like what type? And lasso penalty for the two-dimensional, how does the lasso penalty look like? I draw these things in the class as well. And then fifth, the quantile regression, right? Quantile regression. When we should use quantile regressions? What is the advantage of quantile regression over the multiple linear regression? So how the quantile regressions parameter are estimated? What approaches are used? What algorithm are used to compute these things? And then today we discuss linear mixed effect model. Linear Today we discuss linear mixed effect model. So linear mixed effect model starts with modeling the subjects or modeling with like each individual. You understand, right? So we model with the each school, and then each schools has the subjects. We start with like that way. And when linear mixed effect model is appropriate, what should we check for fitting a linear mixed effect model? If we take a sample of 20 school, you remember that, right? We took a sample of 20 school, we feed the regression model and check intercept and slope. And then we found that those are varying. So that's the reason we have decided to use linear mixed effect model. Okay. So 1, 2, 3, 4, 5, 6, 7. 7 regression models so far I have discussed, right? Okay. So today is the 7th week, right?
Yes.
Today is the 7th week. 8th week will be the exam. 8th week will be the exam. And 9th week, I'm discussing non-parametric regression. So what are the non-parametric regression? 9th week I'm discussing. It's called local polynomial regression. Kernel regression. And then spline regression. These are the regression I'm going to discuss in the 9th week. And 10th week to rest of the week, I'm going to discuss all time series model. Okay. Remember, this course and the materials will be very important for your life if you do the research or if you work in the industry. These are the all predictive modelings that you are going to use. So simple regression and multiple regressions are not appropriate in many scenarios. Okay. So you know what is the fundamental assumptions of multiple regression model? What is the fundamental assumption? What is the fundamental assumptions of multiple linear regression model? Linearity? Multicollinearity? What is the fundamental assumptions of this linear regression model? normality assumption. This, if y does not follow normal distribution with mean, this and variance sigma square, then you cannot use these things. Okay, normality assumptions. What is the difference between y and epsilon? Their difference is in the location. How? It has a normal distribution with zero mean, variance sigma square. It also has a normal distributions but mean x beta and variance sigma square. You have taken econometrics course, econometrics, right? Econometrics 1. So econometrics 1 discuss all of this. And I did not discuss multiple linear regression models because this class when I started, I did not discuss multiple regression model, right? Because I did not derive all of these things. I assume that you already know. You do not know this model and their derivations. You did not see the derivations of this model, beta 0, beta 1, x1i, beta 2, x2i, beta k, xki plus epsilon I, which could be written in the matrix format x beta plus epsilon. This model was not derived, and then epsilon could be written as y minus x beta, then this could be written as yx beta, and then finally differentiating these, all of these things, you see the result is this closed form solution. You haven't seen this? Yes, right? Okay, you have seen this thing. So that is why in order to cover more materials, I did not waste one lecture for this, because I thought that you already knew this thing. This is called the multiple linear regression model. One of the very important assumption is the normality of this. Okay, this assumption is not satisfied, and if data is count, then we have to go either Poisson or negative binomial regression. And lasso elastic net and Ries regressions, they satisfy these things, but they have a multicollinearity problem. So that is why Ries regression needs to be used. Ries regression is used when there is a multicollinearity problem. Okay. What are the other thing I can say? Yes.
Just say if it doesn't follow the assumption that the data is not distributed in the subsequent.
If it does not satisfy this distribution, this distributional assumption, y does not follow these things, and y is a count data. Count data. Data must be count. So even if you see some number someone give you, and then that number looks like a digital number, so that means there is no continuous data. You immediately cannot feed the data to the person, because you have to ask the guy or persons, this data is coming from where? Is this the height? Is this the weight? Weight is also 170 pounds, 180 pounds, right? This is not any decimal. So you can say, well, weight looks like this, can I fit a... But data needs to be generated in a count form. Number of accidents, you cannot say 2.5 accident, right? Number of deaths, you cannot say 3.5 deaths. Right? The data needs to be count format. And in that case, negative binomial distribution and Poisson distributions. Lot of applications. For example, didn't I say number of children born by the women? 3 children, 4 children, 5 children, 7 children. In that case, if you use these distributions, no. It should be Poisson or negative binomial distribution. That depends on the equality of the mean and variance. Yes.
Yeah, what gave us what we used and what we gave us in class for negative binary and the positive equation.
That is, I have given you R code.
Yes, our it has a lot of parts like the upper limits, lower limits, interval, and all this stuff. So are we expected to do that, or we should just run just the output of the equation?
Keep all the code with you. Try to understand all the code. For example, if I give you this is the data, suppose during the exam time, I uploaded altogether, suppose 20 data. Okay, but each of you will have a specific questions. You have to use these data. And by looking at these data, what model you can use. And then if you someone, okay, I will use, this is my dependent variable. And then I see a lot of this dependent variable looks like continuous. So I will go with the lasso because there are a lot of variables in the data. And I want to do the dimension reduction. If you answer those things and write the code and give me the output, then you are getting full credit. And another student said that, well, I look over my data, I found this variable is a count data. So, and then I immediately check mean and variance. Mean and variance is almost same, so I'll go with the Poisson distribution. So you are going to get the full credit.
So what I'm asking is why run the Poisson regression? Am I going to are we still expected to run the other experiments?
Of course, of course, you have to run this because you have done the homework, right? So you have the code. So in the code, you just need to change the name of the variables. Okay. It could be question like this. This is the data for you. In this data, change this variable from these situations to that situations. The variable is a continuous variable. Now transfer it to a categorical variable with the 4 categories, which you already know, right? So after transforming these things, then I said that, well, after transforming this thing as a categorical variable, now you must keep this newly created categorical variable in your model. In addition to that, you have a freedom to choose 3 or 4 other variables. So you will choose 3 or 4 other to feed the model. And after feeding the model, code is running perfect, you will give me the output. Or you will just give me the code, that's it. So whatever homework you have done already, go over all of these things, including linear mixed effect model and quantum regression model. Do this homework. Question will come from there as well. Quantum regression just one line of code, I guess. RQ, it is just the RQ one. I'm discussing a lot of these things, but making your homework easy, I'm giving you the code so that at least it is well set in your head that what type of model we should use based on the circumstances. Data is this, we are going to use that. Data is this, we are going to use that. You understand, right? So predictive modeling, and you want to see the covariate effect. And if nothing fits well, then there is also non-parametric regressions where you can, in parametric regression, you know the form of the parameter, right? You know form. But non-parametric regressions, you do not know y equal to fx. You are given x and y, and then you want to fit like this way. This is called the non-parametric regression that you are going to learn in 9th week. Question?
First, are we going to get are you going to score our homeworks once we haven't graded yet?
I
Wednesday?
I haven't graded the homework because it will take at least 2 days to grade one homework.
That was
So that means I think 2 homeworks, right?
Yeah.
First homework done, then lasso one, and then negative binomial and Poisson, right?
Yes.
I think I will start maybe this weekend. And then I have to make a questions for you. That will take another 2 days.
So how would we know if what we did was correct?
Okay, so that is what you need to know, right?
Yeah.
Okay. Let's see if I can finish grading by Sunday.
Thank you.
Okay.
Thank you.
Louder.
How many questions do you expect?
Maybe one model fitting, some basic questions, especially try to understand when to use what type of model. Maybe all of these questions I will give each one of you, but differing wording, different things. So I can ask you, what type of penalty for the two-dimensional situations for lasso regression you are going to use? What type of penalty? So how the variables are regression coefficients, how reduced to zero in lasso. Okay, then you can say lasso, the penalty is used, is called the penalty that is used, it is called absolute penalty. The two-dimensional, it is a diamond character and it is a discontinuity. So point of discontinuity when it's come, is become zero. Right, this is what I want to mention. So for the lasso one, the penalty used is this, right? I goes 1 to 2 and then it is beta I. So that means there is a beta 1 and beta 2, right? Beta 1 and beta 2, right? Right. This is the lasso penalty is used. So beta 1 and beta 2 can be written in how many format? Beta 1 plus beta 2 if beta 1 comma beta 2 both is greater equal to 0. It could be beta 1 beta 2 if beta 1 comma beta 2 both of them less than 0, minus beta 1 plus beta 2 if beta 1 is less than 0 and beta 2 is greater equal to 0, and beta 1 minus beta 2 if beta 1 is greater than 0, beta 2 is less than 0, right? This is the scenario, right? Because this is the absolute sum. If you take out the absolute sum, this will look like that. So you are getting here 4 lines, right? So 4 lines looks like what type? This is a beta 1 plus beta 2. This is a negative beta 1, negative beta 2. This is a, if I put here beta 1, if I put here beta 2, like this, then this is like this. In this case, beta 1 are positive, right? So that means this is the beta 1 minus beta 2. That is the beta 1 plus beta 2. And this is beta 1 plus beta 2. That is a beta 1 minus beta 2, right? That is a diamond penalty, right? For two-dimensional. So diamond penalty means this is the point of discontinuity, right? Point of discontinuity, right? So in this case, beta 1 equal to what? 0, right? Beta 1 here non-zero, beta 2 is here 0, right? In this case, beta 2 0, right? And in this case, beta 1 equal to 0, right? So now, if you construct a, minimize the sum of square, someone will fall in there. Are you seeing? This one, if you minimize this thing, sum of square, it is coming like that way, it is falling in there. So that means this one is becoming 0. Which is not true for the risk penalty, which is a circular penalty. Risk penalty is this. Which is, risk penalty is this. For two dimension. For 3 dimension, 4 dimension, 5 dimension, this just increase and increase and increase. And even though we are human being, we cannot think about more than 3 dimension, right? 4 dimension, 5 dimension. We cannot think, our brain cannot think. Right? Any other question? Let me see if someone, does the current homework have to be done in R? Yeah, you have a freedom to do, I encourage you to do Python. But if you do in the R, that's is okay, because I already gave you the code. I encourage you to do the in Python, okay?
Professor,
Yes.
how many questions can we expect in the mid-exam?
Up to 30, not more than 30.
Wow.
Yes. if you cannot answer the technical questions, so that means that will be very frustrating thing. For coding thing, other things, if you cannot answer the technical questions, like why you are doing these things, why you are learning this thing, and what situation we have to use these things. These are the things you need to learn. Because if they will interview you, finally, if you get the job, you will have to, they will interview you for whole day, or maybe half of the day. Understand? Half of the day they will interview you. And you do not know. The experiences that I had, because if you go for the interview, unless the peoples are very good, if they have their personal choice for the candidate, then you will see different kind of questions. The experiences that I had, I'm telling you. And also it is said, sometimes employer do not want to hire you. They want to hire the best one in it. That is why they want to. How can they ask you questions so that you cannot answer their questions? The more higher companies you will go, the tough type of questions you will get. Nowadays, before the interview, they will send you a set of psychological questions. Describe yourself in some few words. Okay. So from the following things, how can I explain about yourself? So when you, suppose the interview came for you, and then they will ask you, go through this initial screening process, fill this up. Understand? Then it will take you maybe 30 minutes or 45 minutes, 1 hour. When you fill up, please take a paper and pencil, write down what you are filling. Because that is the initial thing. They will send you some questions of 50 questions, 60 questions. So from the following characteristics, tell us about yourself. Hardworking, friendly, and then say how much you like for sleeping. Those are the questions they are putting all of these things. And then when you answer those 50, 60 questions, please take paper and pencil, initial screening. The exam is initial screening, okay? So, and then paper and pencil, write down all of those things. And then after submitting those things, next week, the first recruiter, they will call you and they will ask you 1 or 2 questions or 6, 7, 8, 9 questions from that 60 questions. And then they want to match whether that are matching. So then matching, so that means, well, he did the background study, okay?
Just how many hours is this assessment?
2 or 30 minutes. 2 or 30 minutes, okay? Okay, so that means you are doing your homework, so that means you know the materials. I'm going to stop in here. I stop sharing the screen. I have given 30 minutes for your life to enjoy. And I finished the class early today. But if you have a question, you can ask me. Yeah.
How many